All right, let's take a look at the theorem about bounded monotonic sequences. All right, it says this. First one, the limit of every sequence that is both increasing and bounded above converges. All right, and number two, the limit of every sequence that is both decreasing and bounded below converges. Right? So let's look at the following example. Right? So this sequence is given in a recursive formula, and we have already proven that this is increasing and bounded above. Right? So we want to find the limit of this sequence. Right? So since the limit exists, we know that we can let the limit to be say L. Right? Then what we can do is we're going to start with the recursive equation, right? Recursive formula. And if you take the limit of both sides, you're going to get this, right? So you can see that the limit of the left-hand side is going to be L, because we know that that's what we assumed here. And you have a 3 minus 1 over limit of an is L. So you end up getting this equation. Right, so to simplify it, first I'm going to multiply both equation by L. Right, then I'm going to put all the terms on the left hand side, so I'm going to subtract 3L and add 1. Right, so we have this quadratic equation right here. Right, so what we're going to do is I'm going to just just use the quadratic formula, and we can actually find the L value. All right, so the quadratic formula gives you two possible values. It's a 3 plus square root of 5 over 2 and 3 minus square root of over 2. All right, it's actually, we have to use the positive version because the negative version is going to give us, let's say, 3 minus square root of 5 is 2 point something, right? So over 2 is going to be less than 1. And the limit cannot be less than 1 because this sequence is increasing, and A1 is 1, so it's got to be at least bigger than 1, right? So the answer is going to be 3 plus square root of 5 over 2. So that would be the limit of this sequence. All right, that's it. I hope that this was clear.